of equal areas. Law of equal areas. Areal velocity. Law of equal areas. Let m be the reduced mass of the particle and the vector r its instantaneous. M be the reduced mass of particle. Reduced mass of particle. Mass of particle. Let be reduced. M is the reduced mass of a particle and vector r. Vector r its instantaneous position vector. Instantaneous position vector. Instantaneous position vector at point A. With respect to the center of a force laying at O, then the origin of the coordinate system. If the position vector changes from r plus dr at B in time dt. If the position vector changes to r plus dr vector at A to B in time dt, then AB vector equal to vector r plus dr vector minus vector r equal to dr vector. The area OAB, OAB equal to dA vector. Shift by the radius vector r in time dt is given by dA equal to 1 by 2 vector r vector dr. Because you let this is the z axis, this is the y axis, and this is the x axis, and this is the origin point O, this is the point A, and this is the point B, and this is the resultant vector. Vector r plus vector dr. This is the vector r and this is the vector dr. At m reduced mass of a particle, r instantaneous position vector. If the position vector changes to r plus dr at A to B in time t dt, then AB equal to vector r plus dr. Then the value OB equal to vector r plus dr, and the AB vector equal to r plus dr minus vector r. This is the value of vector dr. The OAB equal to dA vector. OAB to dA vector, area vector. dA vector means area vector swept by the radius vector r in time dt is given by dA equal to 1 by 2 vector r vector cross vector dr vector. 1 by 2 vector r vector cross vector dr vector. The rate at which the radius vector r shifts, the area is known as shifts. The area is known as areal velocity. The rate at which the radius vector r shifts the area is known as areal velocity. Areal velocity dA by dt vector equal to 1 by 2 vector r cross vector dr by dt vector equal to 1 by 2m vector r cross vector m dr by dt equal to 1 by 2m vector r cross mv dr by dt equal to v. Then this value is mv vector. M cannot be vector, only v vector equal to 1 by 2 m vector r cross vector p moment. Then vector j upon 2m equal to a constant as angular momentum j is the angular momentum j is constant of motion. Constant of motion and m is also constant. Thus the areal velocity of the radius vector areal velocity of the radius vector for a particle under a central force is constant are the radius vector shifts area at a constant rate. Okay. Thus the areal velocity of the radius vector for a particle under a central force is constant, or the radius velocity shifts area at a constant rate. Thus the areal velocity of the radius vector of the radius vector for a particle under a central force is constant, or the radius vector shifts area at a constant rate. Okay, thank you.